Hello, this is Chuck Ridgway, Automation Technology Manager at Horner. Thanks for joining us for another Tuesday live stream. Well, August is IEC month. It's August of 2023. There are 5 Tuesdays in August, and we've got 5 great topics for you this month. Last week, we covered user-defined function blocks, and this week's specific topic is for and while loops in Cscape's structured text IEC editor. Now, I am flying solo today because I did have to pre-record this session. Later this week, there is the Advanced Manufacturing Expo in Grand Rapids, Michigan. So as we stream this video tonight, I will be setting up in Grand Rapids, so I had to travel to the site. If you're in the Michigan area or anywhere in the Midwest, do consider coming to see us at the Advanced Manufacturing Expo. I believe it's at the DeVos Convention Center in Grand Rapids. Okay, so for those of you watching live, we do have folks standing by to answer your questions in the chat section. If you're watching on replay, like a lot of you do, we'd love to see your comments and questions in the comment section, and we will get those answered just as soon as we can. All right, let's take a look at how we're breaking down today's topic. Okay, so we're going to start out by exploring what are for and while statements. We're going to talk about applications where loops can be useful, and we're going to give you all the functionality details and examples for loops, while loops, and repeat loops. Repeat didn't make the title this week, but we're going to be covering it, and we're going to have plenty of demonstrations throughout. All right, here we go. All right, what are for and while statements? So for and while statements, along with the underappreciated repeat, are statements in the structured text language that's available in the IEC package in Cscape. These statements are specifically used to create loops in your program. And why would you want a loop? Well, loops are useful when you need to repeat a section of code, either a fixed number of times or a variable number of times. Now, what are some of the applications where loops can be useful? So let's run through a few of those now. There's plenty more that I don't have on the screen here. But let's start with performing an algorithm on a set of data. So maybe you've got a set of samples and you want to find the average, or maybe the min or the max. That's an excellent place to use a loop. What about if you have a barcode application and you've got a barcode that you're examining and you're looking for a specific character? Maybe it's the terminating character in the barcode, and it's important for you to know where in the string that exists. Well, that's an application for a loop. What about a list of inventory data where you want to search through that list in logic and find a match, and then maybe you use that information to later on, load some process parameters or a machine setup data or something like that for that particular part that you're going to execute? That's a great application for a loop. And how about printing? Let's say you've got a bunch of archive data and you want to sequentially print that archive data to a receipt. Well, loop would be a way to do that also. So again, loops can be useful in a variety of different applications. All right, now let's dive into the for loop. When would you use a for loop specifically? So if you need to repeat code a fixed number of times, that's when you're going to use a for loop. And I've got the syntax there on the screen. And let's kind of review that a little bit. So let's start with the index area there, right after the for statement. Index is a variable that has to be a double integer, and that's going to be used as an index as you increment through the loop multiple times. And don't forget to make that variable a double integer. That throws me off quite frequently. I'll make it just an integer, and then I'll get an error, and I'll have to correct it. Okay, another thing to look at is if you're incrementing index by 1 every time, you can omit the by step section of the syntax, because if that's omitted, you'll automatically increment your index by 1 every time you go through the loop. If you want to index by 5 or by 10 or by 2 or something like that, then you'll need to include the by step portion of the syntax. And then under the statement area there, we're just showing it as one line, but you can have a whole multiple number of lines there and a whole series of statements that are executed multiple times every time you go, or that are executed one time every time you go through the loop. So that is the syntax for the for loop. Now let's talk about some of the specific characteristics of for loops. First of all, they're very straightforward to program. you don't have a risk of an infinite loop, which makes them, pretty easy to use. And as a matter of fact, if you have a fixed number of steps, you're definitely going to want to use a for loop just because of those advantages of not having to risk an infinite loop and a program fault. Some of the specific applications for a for loop would be maybe initializing a list of variables, maybe setting an array, all the elements in an array to 0, for instance. Maybe running an array of data through an algorithm. So maybe you've taken some samples of some data of the machine while it's run, and you want to find the min or the max or the average or that sort of thing. That's another scenario where you'd use a for loop specifically. And then if you're printing a fixed number of characters or processing a fixed length of barcode, again, the key there is fixed, then you're going to be using a for loop as your loop type. All right, let's start out by taking a look at a demonstration on the for loop. Okay, let's take a look at an example program that we've written that is going to use a for next loop. Okay, so here's the example I've got for you. In this main section of my logic here, I'm storing away in a shift register every scan the current value of an analog input. And this shift register is going to maintain the last 10 values of the analog input. So every scan, it stuffs a new value in the shift register. And so at any given time, the shift register has the last 10 analog input values. And what I want to do is I want to find the average of these analog inputs so I can have a more stable signal and that sort of thing. So I'm doing some simple averaging, if you will. Now, of course, this is in ladder, and I wrote the shift register portion of the logic in ladder. But to do the actual averaging, let's use a for next loop. So one of the beauties of IEC is that you can mix and match your languages. So let's go to this other main loop module here that has been written in structured text. And all it's doing is finding the average of all the samples that are contained within that shift register. Now, for convenience purposes in the example, I put the syntax up here with all the details from the help file for for next loops. I always find that that can be handy if I haven't used a language in a while, especially structured text, to include this in my comments just as I'm programming. Of course, if you're using it every day, then you know the syntax inside and out. All right, so let's take a look at the logic here. All right, so ultimately, anytime we find the average of a group of numbers, the steps are we need to find the sum of all those numbers, and then we need to divide that sum by the number of samples in our list, if you will. Okay, so the purpose of our loop is to find the sum of all of the members of the array that's contained in the shift register that has the last 10 values of the analog input. Okay, so this is a simple for next loop. All right, so we've established, first of all, we set the analog sum. We make sure our analog sum starts at 0. And then we also start our loop index from 0 to 9. So the loop index is effectively going to be the index every time through the loop for the array that we're looking at. So we set that from 0 to 9 because that's the indexes of the arrays we're working with. We've got 10 elements in the array. If we're going through an array of 100, it would be 0 to 99. And then every time through the loop, we're effectively going to add the current value in the array to our sum. And then we're going to move on to the next index. And when we're done, we have a sum of all 10 values in this case. And then our average is simply taking that sum and dividing by 10. So very straightforward. All right, let's take a look at that on the bench. Okay, so what I have here is my I/O simulator. And as you can see, as I vary my analog value, the elements of the array, the last 10 scans, if you will, are shown there at the bottom. And then my average is shown at the top. So pretty straightforward logic, really, to execute this. So this is a simple example of using a for next loop to find a sum of an array of values. Okay, so next let's dive into while loops. So while loops will repeat statements a variable number of times. So if you have a section of code that you need to have in a loop and you're not sure how many times you need to go through the loop, then a while loop is very likely what you're going to choose here. And I've got the syntax on the screen. So as you can see, the statements between the do and the end while will be executed while the Boolean expression is true, okay? And that condition, that Boolean expression, is evaluated before the statements are even executed, okay? So it's feasible, if that Boolean expression is false right out of the gate, that the statements will never be executed. Now, some characteristics of the while loop. It can definitely be tricky to program. I don't know how many times I've programmed a while loop initially, and I ended up with an infinite loop on my first time through the troubleshooting steps. So be careful of that. It can definitely happen. And as I just mentioned, it's also feasible that if the Boolean condition at the front of the while loop is false at the very beginning, the statements are never going to execute. And that may not be what you want. It depends on, of course, what you're trying to accomplish. Also, the whole infinite loop is what you have to be careful of. So if your Boolean condition is always true and never goes false, then you're going to have an infinite loop. And if you include, let's say, a real-world input as part of your Boolean condition, then you're definitely in risk of an infinite loop as well, because keep in mind, real-world inputs are only updated or refreshed at the beginning of the scan, and loops always execute within the same scan. So if you're looking for a change in state of that real-world input as part of your condition, it's just not going to happen, and you probably are going to end up with an infinite loop. Okay, so applications where you're specifically going to select a while loop, again, searching through a list. So in general, if you're searching or finding, then the while loop is very likely going to be your choice. And in those scenarios where you're dealing with barcode data or you're printing data and it's varying length, then while is also likely your choice as well. Okay, now let's talk about the repeat loop. That is very similar to, but definitely not the same as a while loop. So take a look at the syntax on the screen there, and you'll see that the statements between repeat and until are executed until the Boolean expression is true. In other words, they're repeated while the Boolean expression is false, okay? So that's a very different result, of course, or characteristic than the while there. And you'll also notice that the condition is, or the condition or Boolean expression is listed after the statements. Okay, so that also can result in the statements always being executed at least once. So as we compare repeat and while, a couple of things I just want to tie up in a nice little bow here. So while loops execute statements while the Boolean condition is true. Repeat loops execute the statements while the Boolean condition is false. So that's a big difference. And then repeat loops always execute the statements at least once, and that's because the statements are listed before the condition. While loops are the opposite. The condition comes first, then the statements. So therefore, there's no guarantee that you're going to execute those statements if the Boolean condition is false at the very beginning. All right, now let's head to the bench and let's take a look at a demonstration of while loops. For the demonstration of the while loop, I'm starting out with my demo program on the bench as the best way to kind of explain what we're doing here. So in this example, we've got a list of inventory items here at the bottom, and there's 32 of them, and they're in an array from 0 to 31. And we want to create some code that allows us to plug in a target value, and we want to be able to search this list and return the index or where in the list that value is found. And that'll be placed right here. And then if it doesn't find the value at all, it's going to return a value of 32, which is obviously larger than the largest possible index, which is 31. So that's what we're going to do in our demonstration. Now let's fire up Cscape and take a look at how we're going to accomplish that. Okay, so in my ladder section, my main ladder section, I am calling a subroutine every time the search inventory button is pressed on the screen. So that's what we're doing here. So this find inventory subroutine is only going to be executed when that search button is pressed. All right, and the code we're using here is utilizing a while loop. And the reason we chose a while loop is because we need to go through an array of values and we need to look for a specific value as a match. We may need to go through the entire array. We may only need to go through a few values in the array. We don't know up front how many times we need to go through the loop until we find the value we're looking for. Therefore, that's why a while loop makes sense in this scenario. So a couple other things to take a look at before we start. So unlike the for loop, the while loop does not automatically increment your index if you're going through an array. So you're going to have to manually set your index that you're going to use in your array as you go through and examine values in our scenario here. You're going to need to initialize that to 0. The other thing you need to make sure happens is you need to make sure that keep in mind, with a while loop, the while loop executes the test before it does and goes through any of the statements. So you need to make sure if you're going to execute a while loop that if you always want to execute the statements at least once, you need to make sure that when you start your while loop, that your conditions that will cause you to fall out of the loop aren't true before you even start. Let's take a look at the conditions that we're going to have in our loop. And there's effectively one condition with 2 parts. So let's take a look at that here. So the main thing here is that we're looking to see if our test value equals our target value. If it does not equal the target value, then we're going to continue to loop. If our test value, which is the value that we are examining as we move through the array one by one, if that value ever matches our target, then we're going to fall out of the loop. Okay, so that's the first thing that's going to cause us to fall out of our loop. The second thing is the second half of this AND statement here, which basically says if our loop index remains less than 32, we're going to stay in the loop. If our loop index ever gets to a value of 32 or higher, then we're going to fall out of the loop. Why do we have that here? Well, one of the problems with while loops is that if you're not careful, you can create an infinite loop if your condition is never met. So let's say that we had coded this with strictly this first part of the condition, while test value does not equal target. And let's say we went through the list and we never found the value we were looking for. Well, we'd be continuously searching and searching and searching, and we would create an infinite loop. So that's not what we want. So we've created a condition with 2 parts to it using this AND. First of all, we're looking to see if the value and the target match. If they do, we fall out of the loop. And we're also making sure that if our loop index ever gets to 32, we fall out of the loop. So again, that's to prevent an infinite loop. All right, now let's take a look inside the loop at the statements we're executing to see what we're actually going to do here. So the first statement is effectively doing this. It's saying, let's take a look with the loop index starting at 0. Let's take a look at the element or the element in the inventory list. Let's say the first element as we start. And let's assign that to a variable called test value. Remember, test value is the variable, one of the variables we're going to be checking as our condition. The next thing we're going to do is we're going to assume that the value matches, because if it does, we're going to fall out of the loop. And if it does, before we fall out, we're going to want to set our inventory index, which is the result we're looking for, to whatever the current loop index is. All right, and remember, if we aren't going to fall out of the list, then the fact that we made these equal isn't going to hurt anything because we're just going to fix it on the next time around. And then finally at the end here, we have our loop index equals loop index plus 1 because we have to manually increment our loop index if we're actually going to work our way through this loop. So we're going to go through at a maximum of 32 times here with an index varying from 0 to 31. Now let's say we find what we're looking for. If we find what we're looking for, then the inventory index when we fall out of the loop is going to be set to the last loop index we used, which is the right answer. However, let's say we get through 32 times, we never found what we're looking for. So I've got a little bit of code here that effectively is saying, hey, if the loop index that we just finished up with here has a value of 32, Well, that means that's the reason we fell out of the loop, because we never found what we were looking for. So let's set our result, the inventory index result, also to a value of 32, because that indicates that we didn't find what we're looking for, because if we found what we were looking for, our inventory index would be between 0 and 31. So hopefully that wasn't too long-winded of an explanation for you. Let's head back to the bench and just verify that everything is working the way it should. So here we go. Let's say we're going to look for a value of 17. And for those of you with eagle eyes, you can see that is in the list. Okay, and sure enough, value of 17 is found here. That's an index of 20. So index of 16, 17, 18, 19, 20. Yeah, so that's the correct answer. Now let's look for a value, let's say, of 99.99. Okay, and here we got a result of 32, because if you look carefully in this list, you'll see there is no 99.99 there. We've got a 9.99 and we've got a 99.33, but we don't have a 99.99. So this is working the way we want. So this is an example of using a while loop when you want to loop a number of times that isn't fixed. Okay, let's go ahead and wrap up our session for this week. Okay, today we learned that for, while, and repeat are statements used in the structured text language to create programming loops. A for loop is preferable in situations where code is to be repeated a fixed number of times, and you don't have much of a risk of any kind of infinite loop if you're using a for loop. While and repeat instructions are used when you need to repeat a section a variable number of times. And with those, you do have to take care to avoid infinite loops, but all loops in structured text are very powerful and a tool that any application programmer should become comfortable with. Okay, so this is the portion of the program where I tell you that we're here every Tuesday at 2 o'clock, whether we're fully live or pre-recorded like today. But as we stream this live, we have folks standing by to answer your questions in the chat section. And if you watch on replay, you can always give us your comments and questions in the comment section. Now, we're celebrating 10 years of the Horner Lighting Group, so check out their great videos on the Horner APG site right alongside the great automation content we have there. Now, don't forget, you still have a chance to sign up for our IEC training course at the factory, which will be held September 13th and 14th. We still have some seats available. Now, next week, we've got a fun show for you. We're going to be going through PID control, but using Cscape's IEC editor, and we're going to be going through the floating point version of PID control that's available in that editor. So you won't want to miss that session for sure. Okay, if you haven't subscribed to our channel, don't hesitate to do so. It doesn't cost anything, and if you choose notifications when you subscribe, you'll be notified every time we'll go live or every time that we post a new video. Okay, so until next week, let's all get out there and do us some good.